All right, ellipses. Ellipses are all points on a plane where the sum of the distance from each point to the focus or foci is constant. An ellipse can either be arranged horizontally with a horizontal major axis, or it can be arranged vertically with a vertical major axis. Either of these two equations are going to be acceptable because the commutative property is going to work here. Alright, so we're talking about the center HK that has not changed at all. Remember, H is always associated with X and K is always associated with Y. That will never change. The major axis is always going to be associated with the value A in an ellipse. That changes with the hyperbola, so please be very careful as you're looking at this and do not get your conic sections mixed up. The minor axis is always associated with B. Now notice that the length of the major and the minor axis is always 2 times A or 2 times B. Vertices are located A units from the center, and each co-vertex is located B units from the center. Foci are labeled as C, and the way to find them is C squared equals A squared minus B squared. An easy way to remember that is it's always opposite of the symbol that you're using to identify the conic section. Eccentricity shows how perfect an ellipse is, or how much near to a circle it is. Remember, and a circle is just a perfect ellipse. That's all it is, much like a square is a perfect rectangle. C over A is how you calculate eccentricity. If it's closer to 0, the foci are closer to the center. If C over A is closer to 1, the foci are closer to the vertices. Here's an example of what an ellipse looks like. When you put it in standard form, you can find A and you can find B, and you can use the equation C squared equals A squared minus B squared to determine what C is, and you can graph those values as well. Alright, our example that we're going to work with today is this one. You have an ellipse that's centered at -2, 3. It has a major axis length of 8 and is parallel to the y-axis. So we'll begin with that information. Centered at 2, -2, 3 means that my equation is going to say x plus 2 squared plus y minus 3 squared equals 1. The only thing left to do is place your A and B underneath each respective part of your ellipse. So the major axis, remember, is always associated with A. So the major axis is 2A. That's the length of it. Therefore, 2A equals 8. If the major axis is parallel to the y-axis, then A is going to be associated with the y value. That means the major axis makes this a vertical ellipse. So I'll go ahead and make that 16, which is A squared. The minor axis has a length of 2. Remember, the minor axis is associated with B, and the minor axis is 2B. 2B equals 2 means B is going to be 1. 1 squared is 1, and we put it there. Finally, we'll draw our ellipse at -2, 3. We're going to go up 4 from there. 1, 2, 3, 4. And down 4 from there. We'll go left 1 and right 1. We have a very narrow, skinny ellipse. Vertically oriented right there. Okay, let's go ahead and talk about some of